Thank you very much. Thank you very much for attending to this seminar. I will start saying that I'm a professor of heat transfer and thermodynamics. And this is a seminar which is an advertisement to people who love heat transfer and thermodynamics. Because while you were describing my activity of research, I would think that I'm a mechanical engineer and I'm really a mechanical engineer and I study, I'm interested, I have become a mechanical engineer and now I feel as a mechanical engineer. It's, I don't know, I think that you will understand that that is not a good thing. It's not a bad thing being a mechanical engineer. It's just being a person in a certain way. And we have in Italy, we have a certain distinction between the many kind of mechanical engineering, and I was very lucky because I have studied heat transfer and thermodynamics, and I worked my life teaching things which are related to heat transfer and thermodynamics. And this is what I will show you in this special presentation on natural gas and aspects of natural gas. I told you that I'm very lucky about it because in Italy, about 20% of mechanical engineers do exactly what they have studied. Sometimes it's better to take a different job. Sometimes they remember, oh, I have studied that subject. It was very interesting when I was a student. I remember it. Oh, now I'm, and they describe a, a very interesting job. They do something which is astonishing, but they remember the subject that they have studied. This is just to say, study now, don't waste your time with seminars, and study and do your job now that is study. And now it began, my presentation began. My presentation starts from here. The engineering building is, I think, 60 years old. When they build this new building, they put these engravings, this marble, this plate of marble, which I don't know if you can see here. It is written in Italian, la parola, il simbolo, il disegno, il modello. I think it's a palavra, right? O simbolo, disegno, yes, o modello. If you translate it in English, it doesn't work because you translate the word, the symbols, the drawing. It's not the drawing. The correct word would be the project, the design, what you do, the way in which you. I will spend some minutes on this because we pass by, because every day you see this. What does it mean? Well, first of all, you can see that they look female. So they are females. So I don't know if they are goddess or they are female engineering like my wife. Yeah. Yeah, they are female engineering like my wife. And they describe what you have to use to be an engineer. You are Leonardo da Vinci, Galilei. Maybe you are working alone or you are the only engineer. Well, when I was working in a big factory, there was 100 of people which was graduated in engineer, but only the chief was called engineer. The other was, hi, ciao, ciao, pleased to meet you. But only the chief was the real engineer, was the responsible. So if you are the first, the chief, or if you are working alone, you should use all these aspects. But before being the chief, before, if you are not working alone, you will be more specialized on one of these different aspects of dealing with real problem, of dealing with real life. And the first of all is the word, a palabra. It's the first thing that you have to precisely describe reality. Because I think that I'm an engineer and I'm working, purtroppo, purtroppo I don't know how to translate it in English, but I'm an engineer, I'm working on reality. I'm not pleased, I would have liked this working on dreams, but I'm an engineer, I'm working on reality. I have to describe correctly reality to face with them, with deal with them, to work with them, to solve problem. I have to describe it clearly. Then, if I would have my students here, they would haven't been so happy for this. But the second thing is o simbolo. Il simbolo, the symbols. I don't know if you can see the picture here. Here, in this page. In this page there are written some mathematical formulas. They have no anyways. But mathematical formula, it's a language. It's a symbol. It's something that for us represents real life. More than representing it, it quantifies real life. Being an engineer makes you in such a way that you want to quantify things. And symbols, the mathematical symbols are what makes you able to calculate a certain value, define a certain threshold, defining a certain value. Remember that they are not correct. If you are a mechanical engineer, you know that every time you know a value, you know where it was a certain error. And with, you know it with a certain precision. But you must anyway quantify it, even if you must bear in mind that there is an error. And then there is o disegno. Well, if I have translated it on Google, and if you write it o disegno, it means the drawing. If you write it disegno, means project. And the basic idea is that again, you have to represent the project with lines, with imagine, with sign, to check it, to make other people understand it, to judge it. It's another important fact that it's useless to remind to you, because I think that you are 50 years at How old are you? At which time of your career are you? So it's clear for you what I'm saying. And finally, I like that this engravings finishes with o modelo, il modello. In my career, it means the experimental test. It means the real life. It means that all the physical law that we know and that we use has been deduced by people that was able to looking at real life. Uh, and they have, when it was possible, they have experimented it in the real life. They have looked it at full scale, at small scale. They have, in some way, repeated the real life, or they have just measured what happens in real life to describe real life, and after that, solving problems on what they have learned. So it's it's a lot. I don't care. Every morning I walk on it and I don't care. But today I'm going to speak about a very, very narrow aspect. I'm going to speak about natural gas expansion. And this is the subject of today's lesson. And the first question is, why natural gas in 2024? The, the answer, there are many answers to the question. The first, IMO. I'm nearly 60s and I am old. Secondly, I am Italian. Italy, in the 90s, have chosen natural gas uh, as the best way out from energy crisis. Energy crisis, I don't know if I'm able to describe to you what energy crisis means for me. Energy crisis, I was born in the 60s, and on Saturday, when I was small children, on Saturday morning, we were free to ride our bicycle everywhere in the town. Genoa at the time was a 700,000 of people, and we were to be, we were five, six, we were free to ride everywhere because for energy crisis, there was no permission to anyone of taking the car on Sunday. Energy control, energy saving, it's easy. Switch off. Doesn't use anything. So in my life, energy crisis and energy saving is something that I have learned from when I was a child as one of the programs. And 20 years later, Italy has chosen natural gas as the best way out for energy crisis. There was there was a lot of good reason that I will try to explain to you. And there is another fact, and I don't know if I'm right on this third reason in which to speak, to continue. I don't know if there is if I don't know if it is a good reason for going on speaking about natural gas. But in my opinion, uh, because I'm old, I'm not so agile. I'm not so fast anymore. I think that we have to do one step by step. It's difficult to do more than one step at the same time. Uh, well, when I am with my small daughter, she does 3 step on, and I go one step by step. Maybe you can do a different step. Maybe you can do more than one step, but not me. So I think that we will get to a good solution to what compulses us to switch the energy supply of every country in the world, working slowly from our solution to better solution. And so I'm going to speak about the present, not of the future. And it's quite easy speaking about the present. I'm a very boring teacher. And this slide is here because I want to remark the importance of reference. Reference is what you have to use. I have taken this information from here, means two things. It doesn't mean that it is true, but it means that anyone else, if he or she wants, can go there and try to read and try to understand what you have understood. So it's for education, it's very important the reference. Use the reference. The second thing is reference. I'm not responsible. I have found the website, they states that the half is clean. Upon their assertion, I can calculate that something. You are going to make your calculation. You are going to be responsible of what you say. And you are going to say that I'm saying this fact, but my fact, my calculation, what I have studied is based on the shoulder of the bench. It's a good idea that you find good reference. Check it. Look at trusted. Check if they have been confirmed or if they are controversial. But start from reference. And this is the reference of my study. It's the European network of people who of a society which deliver gas everywhere in Europe. I will show you later that I have used most of what I have found on their website, but I have also used the International Energy Agency or the Department of Energy in the United States. So I think that I have also used one reference from Italy because you have your own important reference. I have found the distributor of gases in Portugal. And the first thing that you can find is this black, is the demand. The gas demand per country. And I told you that is that I'm Italian. I don't know if you see my mouse that is working. I'm Italian. The 22 and 23, there is a big reduction. You can imagine. Wow. There is a big reduction, but we are the first or the second column of this. So we are the biggest consumer together with Germany. Remembering that Germany has twice the people that you can find in Italy, and the, the, the factories are much higher. But in Germany, they have coal, which is definitely worse. That is definitely worse than natural gas. It's not European Union. You can see that the third column is United Kingdom. The fact that differently from Italy and Germany, they have gas. So they have a huge demand, but they are also, they don't buy almost every cubic meter of gas that they use. What is it? It's here. The share of energy which is covered by gas in Portugal is much less. It's true that you have people than here, than in Italy, but you have different choices. You have done different choices and you use different choices. I think that you have this windmill, you have such a large amount of windmill that that we don't have. We are in Italy. We are very in a late development for wind. So I think that it could be easier for you doing two steps instead of one, but for us it's not easy. So I hope that I am convinced that I need to speak about natural gas because we use a lot. But adding on it, look at this slide. This is the gas consumption for power generation. And in the last 3 years, I just say, I don't justify, I just say that you can assume that more or less, even if you don't use combined cycle, the CO2 production, which is coming from natural gas, is 70% the one which is coming from oil. And maybe less if you compare it with coal. And so electric generation in Italy has switched completely to natural gas, and we have closed or revamped the central, the power units to natural gas 5, 6 years ago. So now we have a huge dependence from natural gas. And we have to distribute a large amount of natural gas everywhere in Italy. As I told you, there was a huge development of the network of natural gas 20 years ago. Again, Portugal is about 10, 12% has electrical power that has been produced by natural gas only for 12%. So it's not the same. Even if you remove 20%, there is a blackout. This is about historical in time, and the only thing that I want to show you is that the natural gas consumption in Europe till 2023 is almost constant. Natural gas haven't been overtaken yet. What has got a big reduction is hard coal, because maybe finally German will switch off their hard coal power plants, but I'm not sure. And now I'm looking to another aspect. It is, look at the title. I've copied it from the website, is evolution of summer gas supply. So first of all, is not consumption anymore. We are going to look at supply, what they supply to us. And secondly, look at the word summer. It means that if you look at consumption, summer consumption is less than 1/3 of the winter consumption. We use natural gas for power production and for heating, and it depends on the amount of air climatization that you have. Electrical consumption is lower in summer than in winter. Not anymore. Because if you have a widespread amount of air climatization system, the electric consumption in summer increase, and sometimes it overcomes the one in winter. Anyway, gas for heating is bad use of gas. Anyway, gas for heating in winter is much, much more than the one for cooling. And so these are pictures about a low consuming period. And you can see that we are here, this slide is here because what I want to say, energy is politics. No, energy is money, and money is politics. And relations by country determines the market, determines the relation, the links, the energy links between country, the energy links between countries, the exchanges. And you can clearly see here that I have to introduce another word that I will repeat later. Till now, natural gas has been, as a strategic source of energy. And why it's strategic and which are their features, I will try to explain it later. Anyway, if you look here, the red bar is Russia. And till 2021, the highest bar was the bar of the natural gas which have been imported by Russia. Just look at the red bar. It was increasing, increasing, and increasing because there is a large availability of natural gases in Russia, and if you close a gas duct, if you close the pipe, there is a big reduction, and there is a big reduction that has been bigger. This time it has happened for a terrible thing like the war, but it happened in for a different reason in 2014, and the valve was closed. So in one day, they can stop the supply. And this is one reason, because the capability of using energy and the possibility of having energy from other countries depends on cooperation, peace, and collaboration between countries. The other thing that you can look at is, yes, Norwegian is always the same. National production doesn't come from Italy. And then you can see the black line. The black line is a different kind of gas. Is liquid natural gas. Liquid natural gas is important for Portugal because it's the way in which natural gas is supplied to Portugal. In Italy is worth of from 5 to 20% before the war, from 5 to 30% now, but it was not so important. Liquid natural gas is a key feature of Portugal. It can be one of the key points of Portugal. I will say to you later that the possibility of the key point of Portugal, in my opinion, the most important aspect of natural gas in Portugal gas will be natural gases, I'm sorry, liquid natural gas and storages. I will try to speak. But which is the difference from liquid natural gas and natural gas? I will try to explain it. It's not just the fact that one is liquid and cold and the other is I start from natural gas. Oh, I love this one. When I show slide like this to my student, I think that they think that I think that they are stupid. Because it's a calculation. It's a division. My mind is that you must do the division. You must do the division, and you must show the result of the division. You must represent your result in such a way you don't forget it, you understand it, you, not the person who you are speaking to, you understand it as better as you can, and you can represent it. So, have you already understand what I'm speaking about? I'm speaking about the volume. I'm sorry. I think that you know what is an heating value. I think that you understand what is a density. I think that you know the units of density and of the heating value too. And I think that I wanted to understand the volume which is occupied by a same amount of a certain fuel, of a certain energy sources, of a certain energy source, in case I would have the same amount of energy, the same amount of uh, kilojoule or uh, terawatt hour or something like that. And the result of the division is there, is in the table, but they are about volume. So I have drawn many uh, balls, which has the radius that uh, give that volume, using as a reference an oil. There is a big approximation because density and specific heating value depends on the real composition. So, but I think that the error is less than what I can see. And oil is the reference as a radius of 1. Diesel, gasoline are those. The second ball. The third ball, I think it's important in Braganza. Or if you are my mother-in-law live in a place where even if you are even if she is in Italy, there isn't any natural gas, and she use LPG, we call GPL, liquid petroleum gas, like here. You can see more or less they are this they occupy they occupies they occupy the same volume if you want the same energy. Natural gas need a huge volume. As the ball that that is not inside the slide. But if you increase the pressure, if you compress it, the density increase, so you can reduce the size of the ball of natural gas that you need for the same amount of energy. And you can decrease a little bit more if you increase the pressure up to 75 bar. This number are not there by chance, because they are there for a specific region, because in Italy and in the world there are, I can say, 3 main kind of natural gas pipeline. They are of 3 high pressure natural gas pipeline. The first is the lower one at 25 bar. The second is standard longer running pipeline at 75 bars. There is another level of pressure that is commonly used, that is 110, that is commonly used to cross the sea. So we will see that there are a lot of pipelines that is coming from, that crosses the sea, coming from Africa, coming from Greece, the famous Nord Stream 1 and 2. In those, the pressure is higher, but most of them are at 75 bar. There is another step. And the volume of liquid natural, the volume needed for giving the same amount of energy with liquid natural gas is very small, is similar to any other. So the intensity, use the word of intensity at this point, because they are kilojoule per cubic meter, is very high for liquid natural gas. Okay? So this is the first presentation of natural gas. And it was very easy. It's just taking a book, making a multiplication, divide it. Look at the word in this way. Calculate it, evaluate it, compare. I have done also 3 different comparisons, and it's for pipeline. And again, there is a comparison at the same amount of flow of energy. If you want to transfer the same amount of energy in a certain time, you need a ship, you need an electric wire, or if you are using oil or natural gas, you can do it as well as with a pipe. And I have calculated with only for oil, natural gas at pressure of 25 and natural gas at 75, because I don't think that is possible to have pipeline of liquid natural gas, because it's too cold. It's minus, I don't remember, minus 70 degrees C. It's too cold. It's too difficult. You cannot have long pipe of liquid natural gas. And most of cases, it's better to transfer oil than to transfer gasoline, diesel, and so on. So I have studied less. I present only 3 results. And the pipe are those. The cross-section of the oil at the same amount of flow of energy, so kilojoule per second, is much smaller than the one that you need for natural gas at 25 and natural gas at 75 bar. At this point, I have a question. Can you understand why this slide is wrong? In practice, why this slide is wrong? Because I'm going to buy a pipe. They will not build a pipe for me. There are standard cross-section of pipe, and I will buy a pipe of 100 centimeters, 80 centimeters. I will buy in inches, or I will buy some standard pipes. And the correct approach is the other way around. When I have a certain cross-section of pipe, the oil will carry a larger amount of energy than the one that can be taken by natural gas that flows in the same pipe. If you have a look at the table, you can see that I have account for velocity. Oil is a liquid. I have to make it flowing at a lower velocity than gases. So I have selected 6 meters per second for oil and 20 meters per second for gases. Okay? So this is the first presentation, is the physical presentation of natural gas. And so I have to bear in mind these facts. And then I go to the other aspect. I am very happy that I'm a professor. I can study these aspects, but my colleagues that works in factory have to deal mainly with these aspects, which are money, costs. So I need to make a presentation of natural gas also from a point of view of money. And I've taken from a presentation which is was in German, so I hope that I correctly understood the graph, because I wasn't able to understand what was written there, because I don't speak German and I didn't translate that. But more or less, the cost of transportation is much higher for natural gases than for oil or shipping or the cost of our coal too. The cost of transportation, so, is much higher. The other fact you can notice is that the cost of liquid natural gas doesn't start from zero. If you want to create, you don't find liquid natural gas in nature available as a primary source. You get natural gas. And if you want to create, if you want to generate liquid natural gas, you must condense it in a huge refrigerator that must go down to -70. So it's low efficiency, it's high thermodynamic cost. But you can recognize that the density of the liquid natural gas is the density is much higher. And so if you want to transmit it at very long distance, the cost of liquid natural gas doesn't increase so much as the one of the cost of transferring natural gas with pipelines. This seems cost, but is politics. It means that you can supply countries which are very far from you, or vice versa. You can purchase liquid natural gas from countries that are on the other side of the world. That what's happened in Japan, that what's happened also in Portugal, you purchase natural gas from Nigeria. Yes. That's not so far. But we have started in purchasing natural gas from the United States. That's by very far. And again, if you look around, you can find 2 or 3 different publications that show picture like this, that states that if the distance is not so much and your consumption are very big, you can use pipeline. When the distance increase, it's better that you go on ship. It's better that you use ship with a liquid natural gas. After that, This is a very precise presentation. You can use a different kind of absorption of liquid natural gas together with physical absorption to material. It's it's quite easier to, without entering in complicated details. Let's read this word. The word stranded. Stranded, I think that you can say sprecato in Italy, wasted, not reachable, useless. It doesn't matter if you have a large amount of natural gas in Kazakhstan. If it is too far and you want a too short amount, it's better that you waste it because it's not economically viable to go and take the gas there. Just to say is that, remember that before in the 90s and before, one of the biggest source of CO2 that there was the fire on the top of oil extraction. I think that you know that there were a lot of oil extraction far in the Asia, and there was no pipeline that was coming to Europe where we use natural gas. So they burn natural gas in torch and waste it. Like I don't know, like buying a lot of gasoline, making and throwing away half of that, and producing CO2 anyway. No, it's finished. There are a lot of pipelines. Yes. The problem with natural gas is that you need a network. I cannot supply to you and you cannot supply to me if there isn't any pipe which connects me and you. And if there is a pipe, it's a connection. We must be in good, we must trust one in the other. And the network is not pipelines, is also energy hub, the liquefier, regasifier, what you can call it, and storages. Okay, this is the network. Don't look at it. Download it, print it, put on the wall, or throw it away. But it's always the same website, and they reports the size of the pipe and the capacity of the pipe as energy. I prefer, this is a seminar, I can speak freely, I can bore you. And so I've placed here a lot of different pictures, which are zoom of that picture. The first is Europe. What you can see, there is a strong connection to Africa in Spain. There are two very strong connections to Tunisia and Libya too in Italy. After a big controversial situation, there is a strong connection from Italy to Greece. But it's not a connection to Greece. It is a connection to Armenia, a place like that. you can see that there is a strong line here that is a connection that from Italy goes to Russia. But there is another one that from Germany goes to Russia, and there is a third one. I will see. It's very nice. Look at here. There is no connection from France to Italy. Instead, there is a connection which is effective and it works in both ways between Portugal and Spain. And there are some blue, yes, some blue place. One is here, I have written the name, but I don't remember. Since it is the liquid natural gas regasifier of Portugal. You have, I will show you some pictures that are very nice for me about this blue point that is the regasificatore di Livorno, the regasifier of Livorno. You can see Italy, there are two pipes from Africa here and one pipe here, and this big pipe, but the biggest are the one which is coming from Russia that are not working so much now. And this is you. This is the Sinch. I'm sorry. And this is the connection to France, to Spain. This is another website. This is the Italian society which own the pipelines. And you see that they have drawn the lines, and you can understand that there was a strong connection between Russia and Italy, but also that there was a lot of plans of the dashed line are plan of building new pipelines. And you can see that there is a strong connection to Mar Nero, Black Sea, Caspian Sea, and Arabia, Iran, Iraq. That this is the line which is goes. In this website, there is also the point of access of natural gas to Europe. The black point are the point into which the gas goes into Europe, but it starts from the sea, so it gets to Norwegia, but it is owned by this country. So also Great Britain has a lot of pipe that supply natural gas to him, but they take it in the wells in the sea. We take from some country that supply natural gas to us. Again, Italy. Again, Spain. And across. Oh, it's interesting. There are some lines here. You can see there is a big network that means 75, more or less, it means 1 meter pipe and 75 bar. So, and then there are smaller lines that go to the coast. This is a picture that is diffused in every country, but it's important in Portugal because it has a relevant way with respect of natural gas consumption of the country. That is the storage in empty caves. These caves are under the sea, and they are storage. They are place where you store the gas in summer and you take the gas in winter. So uh, I wouldn't, I'm not able to do this, but you can buy gas when it has a low cost and you can sell or you can use it in winter when the cost is much higher. And on this website, you can look to what you want. The amount of gas which comes from still come from Russia, or this is from before the beginning of the war, or that cross the border in any. And you can also look at pipelines. Yeah, because you have pipelines that start from the sea. It means that there is a huge well somewhere that serves some countries. And you can see that there are also pipelines that do strange turns around other countries to move in a, to turn out the problem. Again, you can see it in a different way. This is the same thing, but it's the name of this well that is Leviathan. It's very famous. It's very big one. So I think that I have done the description of the present, that is natural gas, and I'm sure that I'm not able in speaking you about the future. Someone says that the future is H2. Is it? Is it not? I'm not able. I'm not able to say to you anything. And this table is a map of the infrastructure that are still present, that are already present, or that will be designed and deployed in the case H2 will be an important way to transfer energy from one place to another. If you look at it, a certain part of it are natural gas pipeline. Someone is thinking at the fact of mixing hydrogen with natural gas to have another vector of energy. So in most of cases, they would, I don't know. There is the possibility that in the future, the infrastructure will be the same of natural gas. Too much. It's always the same picture, always many different sources, and so you can spend weeks. And again, late, tell me. This is the share, and you can see that. Yes, it's just a cut and paste of a picture, I think, and you can see LNG and other gases which are coming from the other part. This is the second quarter of 2024, so it's today. And as I told you, the number are the same, but the share changes if I count for storages, gas which is coming from storages. We are at the end of the heating period. We are still using a lot of gas which was present in storages, which is 20% today is coming from storages. And I think it's strategic because the LNG create links between two countries. Also, LNG create links between two countries. And the link is an internal link, is the capability of getting LNG and producing NG. You get liquid natural gas that you can't use unless you regasify. And saying this, you have a certain capability, and it's always working with a certain flow level. Apart certain period, it will be maintenance, I think. But the flow of Portugal is, Portugal LNG, this is the amount of gas that arrives to Portugal, and it's quite constant. I like this story because I like this picture, the two pictures, because I was preparing to this speech, and I was looking data for OLT, LNG Gas Toscana, which is at present the biggest in Italy, which is a very big ship. It's not a ship. It's the one on the right. It's the red one. Well, they are always red, but it's the black one. The one on the right in this picture, the one on the left in the picture above, is the one which is reported alone in the first picture. It is a gasifier. Can you see? This is like a building, like a factory here, and you have a pipe which goes down, and this is placed at the beginning of that red line that is in the middle of the sea. So the first, I'm not able in showing it to you. Yes. So, okay, I do like that. Fine. Those balls are the storage. So once in a week, once in every 3 weeks, there is a ship like the one on the left in the bottom picture that arrives, transfer the LNG gas to the gasifier, and then goes away. It takes 1 day, 2 days. And then for a long time, this gasifier gasifies the liquid gas and sends it to this pipe. And I was looking at consumption. I'm sorry, I was looking at production of this gasifier, which is the biggest in Italy, that is in front of Livorno in Tuscany, and the production went to zero. Which is the problem? It's not a problem. Is that heat transfer in front of my home? It is in the harbor of Genoa because of maintenance. It will be in Genoa for 2 or 3 months because they are going to make maintenance. So I've taken a lot of pictures. I have a picture in which you see the building and after. So you can clearly see that you have 3 balls for storages. Sorry, four. 4 balls for storages and the gasifier. The gasifier is a big building. I think that is 300 meters. If you look at, I don't, you can look. Oh, the name is FSRU Toscanas. If you go on Vessel Finder, you can find it. It's big. So it's not working now. It's again strategic. You need to do maintenance. And when you do maintenance, you cannot produce, you cannot have, you cannot supply natural gas. Even if you buy 5 ship of liquid natural gas, if it doesn't work, you cannot gasify. So, stop. I'm going back or I have the plan? These are exchanges done. I don't want it. So I want to spend another fact about natural gas is about that the consumption of natural gas is increasing also in Portugal. And if you compare this slide with another one that I haven't found in Italy, uh, there is a big difference that is the supplier. You have Russia is the one at the bottom, which has gone down. But there is anyway an increase. A big increase. Yeah, the green one is the United States. You have an increase in the gas, which is supplied from the United States, but the large part is from Nigeria. But I think it's the best choice for, it would be the best choice also for us. I don't know why. Then, looking at the presentation, I have found this graph and try to be an engineer. I'll try to be an engineer. On this graph, you can see the stock level in storages as a function of time, starting in 6 months that are April, May, June, July, August, and September in 5 different years. 1920, no, 19, 20, 21, 22, and 23. So the level of gases stored in your storage, that more or less means the pressure of gases in storage in this cave, in this huge cave that are under the sea level for you. But this is at European level. It's not Portugal. Looking critically at this picture, you can see again a strategic effect. The strategic effect is safety. No. Is security. No. It's being safe. It's being certain that you will have a certain amount of natural gas in November. And in fact, in those years, that was before the war, people who managed the storage consumed the amount of gases that was stored in the storages a lot. They had empty caves down to 30%. This means that you can exploit 2/3 of a cave. You go from 30% to 100%, from 30% to 100%, you exploit 2/3 of the volume. After the war, the lower level is 50%. After the beginning of the war, it is 50%. This means that people who manage, or the European country, all the caves, more or less, doesn't trust to get storages that are emptier than 50%. And this means that the physical exploitable volume of a storage is 50% of the, no, I'm sorry. The exploitable volume of a storage is 50% of the real physical volume. It's another engineering effect that is affected by relation by country, politics, volume, and division. So we, as an engineer, we must do division, but we must to pay attention to the word because it changes the volume available. Okay, I will not describe it now, but you can find a lot of data also from the distributor of the Portugal gas that is on this website, and it gives you a lot of data, the amount of gas that entered in Portugal that day, that month. There is another place in which they give you the level of storage. So just to see. So, but I will finish, but I haven't started yet because my lesson is on pipeline, or to say it better, on gas suspension caving in the pipeline. You have 75 bars, and you can send 75 bars to the town. It's impossible if you have a broken pipe. Gas will go as my glasses everywhere. So I have looked also at pipeline. I still look at pipeline. I have found I have looked at in the International Energy Agency. I have found a publication which the title is Security Policy Portugal. It's strange because there is a security policy Portugal, a security policy Italy, no one other country. No, if you look back in the past, there was other country, but in the two last year, there has been a publication on both on our countries. And you can find this picture. Look at it better. You are here. It means I don't have any pipeline here, but it's planned. And the strange thing is that there is no connection to France, to Spain. The connection, yeah, it's not so difficult. Well, you have already a connection to Spain in Badajoz, And you can find it down that in some period it goes one side, and the other, in some other period you supply gas to Spain, in some other period the Spain supply gas to you. So, but the strange fact is that in this very precise picture, there is no second connection from Braganza to, and it can be useful, can be interesting, it can be, if we would have decided, we have decided to go to make the connections. Stop. Finally, the subject of the seminar is the gas pressure reduction, authorization, and measurement station. I forgot to say that methane hasn't any odor. People who use methane knows the odor, but the odor is added. There are some special substances. I have written it because I forget mercaptano, butyliol, tetrahydrothiophene, that has a bad smell, that bad odor, and they add 0.1%, maybe less, and you can easily smell it. Because in case of leakage, in case of leakage, you wouldn't have smell the methane. Deodorization takes place when the gas gets out from the big pipes and goes into the town. So if there is a leakage from a huge pipeline, you doesn't smell it. But they have a lot of time. They measure pressure, so it's not. And so a gas pressure reduction is like the one that you can see on the left. This is for more or less 100, maybe 200, between 100 and 200,000 of people. It is the biggest cabin in Genoa. I can't show this picture. It's similar to the one. There is a big valve, like the pressure cooking valve, like the valve of a refrigerator, like any control valve. And there are two heaters. What you can see, this green pipe, this green vertical cylinder. I'm sorry, I have to read this gray. These gray vertical cylinders are big heat exchanger, which increase the temperature of the natural gas before expanding it into the expansion valve, into the throttling valve, and sending to the low pressure net. This is the gas supply. The subject of this seminar is that you have a gas at a higher pressure and you need it at a lower pressure. And anyway, you have to increase this temperature because it's not a perfect gas. And during the expansion, the temperature goes down. So you have an heater there. And instead of heating and sending them to a throttling valve, it would be better to send to a very small turbine. You send the gas to the natural gas to the turbine. That is a not centripetal. Yes, it's a centripetal turbine that take the gas and generate works. Not so much, but you will see it has an efficiency that is 70%, 80%, can be more than 100% in one period of the year. Those who have studied thermodynamics should get up and go away because it's impossible, such an efficiency. The fact is that you don't pay for compression. The natural gas have been compressed by someone else 3,000-4,000 of kilometers from you, and you are just expanding it. So the big efficiency comes from the fact that you don't have to pay for compression. Compression is for free. And yeah, I'm not able to show it in a different way. This is a little bit more technical part. It was, again, is natural gas. Natural gas is not a perfect gas. If you look at this table, that is pressure, temperature, and I go there. It's a problem because the natural gas is not pure. There is always some water vapor, some other materials that solidify inside of the valve and block everything. So we must be sure that the temperature is above 0 degrees. And speaking to the people who manage the expansion, they say, I want to practice 12 degrees at least. What does it mean? If I want to maintain, if I have an expansion, was an interview network that that describe the future where that this cabin, I buy this cabin, I I have a needle which is fed with methane. I use methane to I burn methane to produce energy to increase the temperature of the methane before expanding it. I don't know why it's duplicated. Maybe it's the wrong presentation. It's not the final one. Doesn't matter. So just to repeat, the good is that you need preheating, and you preheat the gas using gas. In case of a single valve expansion or throttling valve, it's the case from A to B. In those cabins in which you have a high pressure jump, you need preheating. Okay, this representation was done because I was not sure that you know what entropy is, what is a pressure and a temperature entropy diagram. And so I would have explained a bit. This is a natural gas temperature entropy diagram. Those the expansion are isoenthalpic transformation, and you can see on the left the increase of temperature that is needed to get to 12 degrees at the end of the expansion. You can understand that preheating it's worth of about 0.15%. I just compressed the picture. It's a common pressure entropy pressure. It's a common entropy temperature diagram, Mollier diagram. Again, what would happen if instead of expanding in a valve, you would buy a turbine? If you would buy a natural gas turbine and you take gas at 75 bar and you need to increase the temperature a lot up to 70 degree, 80 degree. So you need to consume 3 times the gas that you was consuming before, but then you send the natural gas to the expander and it produces power. And the power is, the efficiency is more than 70%, but in those days in which gas arrives hot because it's summer, you could receive more power than the energy that you have, the energy per second, than the thermal power that you have consumed to increase the temperature of the gas. So it's a very, very high efficiency. Okay. I'm going to reply to your question after showing this. This is the last picture. And which is the problem? It's always the problem that I think that you know very well. The problem is the time. problem is the profile of power production. As I told you, you are expanding the gas, and you expand the gas when you consume it. So these are typical gas profile during many days in different period. This is in spring, but more or less they look similar to the one in winter and to those of summer. Nobody's cooking and nobody's heating during night, and the consumption is very low. Then everybody starts heating, cooking, working, and doing everything. And the consumption of gas is very high in the morning. And the profile of power generated by your active, expanding system will be equal to the profile of natural gas consumption. You have an advantages. People consume a lot of gas when it's cold, and when it's cold, you need a lot of power. So it's you are a certain kind of there is a certain kind of phase of being in the same phase of consumption, but there is another fact that is again connection. You are not free. The power that you are going to produce is connected to the consumption of gas. And freedom and connection are one against the other. I don't know which is better. Thank you for your attention. Yeah.